All right, so I understand some of these problems, arithmetic, geometric, may be a little bit difficult, but really it comes back to problems like number 1 and number 3. If you can do those two, we're just going to sort of expand it to the other. So what I mean by that is in problem number 1, you don't know, obviously, the first term. We have no idea what term number that is. We're missing one, and then we know this. So if we just think about, okay, we're going to rearrange this a little bit. Let's just call this a sub 1, and let's call this a sub 3. This is a simple concept because you can see that there's only one number in the middle. So there's probably lots of ways you can just figure this out with just basic arithmetic. But let's make this a little bit broader, sort of, so we can apply it to other things. If you subtract the two numbers, they told you it was arithmetic. That was the important part. The fact that it's arithmetic means we're going to subtract. If it was geometric, we'd have to multiply or divide or something. So it's different. So you have to know if it's arithmetic or geometric. So with this, we're going to take 45 minus 37 and find the difference there. Now, if you think about a sub 1 and a sub 3, subtract these. We're going to divide by 2. This gives you the difference. 4 is your difference. And now you can just add 4 or subtract 4 or do whatever you're doing. You can tell the numbers are getting larger, so your signs don't even matter. You could even do this backwards. Like you could have these switch and get a negative 4, but you can tell the numbers are getting larger, so then you would add 4. In problem number 3, just to show you one that's geometric. Again, same situation. No real idea what's happening. Where are we in the sequence? We just know we have a number missing. This is where doing all those arithmetic and geometric means. This is this. This is what this is. All right, but I'm giving you the little shortcut version. So you know that we're multiplying to go from term to term. So undo it, we're going to divide. So take the furthest one down the line and divide by the one towards the beginning of the line. This is going to give you, just like this, we call this a sub 1 and this is a sub 3. This is not 2, this is actually r squared. So your power is the number, your little subscript number subtracted. So 9 is equal to r squared, and of course you can tell that you're multiplying by a positive 3, hopefully, and not a negative 3. You will have to figure that part out. R equals 3. And then you can tell that the numbers are going negative, positive, negative, positive, negative, positive, so on. Actually, sorry, that would have to be a negative 3. Actually, you can't tell. You don't really know because they don't really give you enough information here, so that's unfortunate. So I guess we don't know. You pick. Both of them will work. All right, so let's fast forward this to problem number 7. So we have a sub 12 is 5. And it goes on for a long time, and we get over here to 49, and this is a sub 32. They tell you in the directions is arithmetic. This is how you know what to do. So now we take 49 minus 5, and then you take 32 minus 12, and that goes on the bottom. So these are your values. These are your term numbers. And then we just figure this out. So this will give you like 44 over 20. And divide that out. So our difference is equal to 2.2. Okay, so that's one of the questions. In fact, it was the first question. Find the common difference. Now, your explicit and recursive formula. Explicit is the formula. Explicit is the formula. Recursive is you going, oh, okay, I know how to go from term to term now. But the only problem with recursive is we need a sub 1. So we're not quite ready for either one yet. So we need a sub 1. So if we think about what a sub n is, this is the formula I'm talking about. This is how you do explicit, whether it's arithmetic. I'm having trouble talking and writing. Whether it's arithmetic or geometric, you do this explicit. This is your explicit for but obviously there's a different one for geometric. So we know, I'm going to go pick on the small one. So 5, we know this is 2.2. I know this is a 5, but I don't know this. So 5 is equal to 2.2 times 4. If we do all that work, this is 24.2. And we get negative 19.2 is equal to a sub 1. Oh, okie dokie. Now we're ready to go. So for recursive. Recursive means, hey, what's going on around it? What's happening before or after it? So you have two parts here. A sub 1 is equal to negative 19.2. All the other terms are based on taking the term before it and adding, because D is positive, 2.2. Explicit is your formula, which is basically right here. We can figure this out a little bit better. It's any of these. We know all these parts. So we know that A sub n is equal to, I'm trying to do all this in my head and talk, your first term, and you add that to this. So we get negative 21.4. Yeah. You have to do the work. And then, of course, we're going to add 2.2, and I did that in my head, so you can have that switched around. All right, so let's take a look then, I guess, at number 9. I don't know, I'm just trying to, you're saying explicit and recursive are tricky? I understand that. Oh. This is like the weirdest setup, sorry. I just try to push that out of the way. So we're looking for common difference. Oh, they tell us that. So we need explicit and recursive. We have everything we need. So for recursive, we know that a sub 1, they tell us that, is negative 4/3. And then a sub n will just be the term before it with your difference, minus 5/3. Explicit is the formula. So the formula is a sub n is equal to the difference times n minus 1 plus a sub 1. So let's figure this out. A sub n is equal to our difference, which is negative 5/3 times n minus 1 plus a negative 4/3. Distribute, simplify, write your explicit formula, and of course that should be in fractions because there's only fractions in it. Hopefully that's enough to sort of fill in your gaps for you and get it started.